Numerical number 21. A resistor of 6 ohm is connected in series with another resistor of 4 ohm. 6 ohm is in series with 4 ohm. 6 ohm and 4 ohm. Potential difference of 20 volt is applied across the combination. So that can be done by a battery. So let me draw a battery here which provides potential difference of 20 volt. Calculate the current in the circuit and potential difference across 6 ohm resistor. Potential difference across 6 ohm we want to find out V1. Potential difference across 4 ohm will be V2. And since 6 and 4 are connected in series, we know that V1 plus V2 is equal to V. Alright, so to find out V1, we can use the formula IR1. R1 is known 6 ohm, but we don't know the current. So first we'll have to figure out what is the current in the circuit. And to find out current in the circuit, we use the formula E is equal to I into R plus small r, where E is the EMF of the battery, 20 volt. 20. Current we want to find out. What is R? Total external resistance. 6 and 4 are connected in series. So the total equivalent resistance becomes 10 ohm, which I am writing directly here. Plus internal resistance of the battery is not given. So we will consider it as 0. So whenever the internal resistance of the battery is not mentioned, by default you can take it as 0. So 20 is equal to 10I and current is equal to 2 ampere. Now we substitute the value of this current in the formula V1 is equal to IR1. Current is 2 ampere, resistance is 6 ohm, so potential difference becomes 12 volt. So potential difference across 6 ohm is 12 volt, right? So can we easily find out now what is PD across 4 ohm? Yes. We can use this formula V1 plus V2 is equal to V. Voltage of the battery is 20. V1 is 12. So V2 must be 8 volt. 8 volt. You can also find out V2 using the formula IR2. Current is 2, resistance is 4, 8 volt. Next, two resistors of resistance 4 ohm and 6 ohm are connected in parallel to a cell to draw current 0.5 ampere from the cell. Draw a labeled circuit diagram of this arrangement. 4 ohm and 6 ohm resistors are connected in parallel to a battery or to a cell, and because of this arrangement the current drawn from the cell is 0.5 ampere. So this is the circuit diagram with labels, and calculate the current in each resistor. Okay, so first of all we will have to find out the potential difference across 4 ohm, right? So if I want to find current in 4 ohm, I must know what is the potential difference across 4 ohm. I must know what is PD across 6 ohm if I want to find current through 6 ohm. But EMF of the cell is not given here. EMF of the cell is not given. That's fine. We can find out what is EMF. How? Let us see. E is equal to I into R plus small r. But as I mentioned earlier, internal resistance is not given, so we can consider it as 0. So now this becomes E, or terminal voltage, is equal to IR. What is R here? R is nothing but RP, and RP is 4 into 6 upon 4 plus 6, that is equal to 24 upon 10, 2.4 ohm. So now V is equal to IR, current is 0.5, into resistance is 2.4. So voltage becomes 1.2 volt. Okay, so voltage of the battery is 1.2 volt. Now since 4 and 6 are connected in parallel and that combination is directly connected to the battery, we can say that potential difference across 6 ohm is 1.2 volt and potential difference across 4 ohm is also 1.2 volt, right? Because in parallel connection, each resistor gets the same voltage as the voltage provided by the battery. So now our task becomes easy to find out the current in each resistor. So first for 4 ohm, current is V upon R1 1.2 divided by 4, that is 0.3 ampere. So now for 6 ohm, we can say that the current through 6 ohm is total current minus current through 4 ohm, 0.5 minus 0.3, that is 0.2 ampere. Or we can also find out the current in 6 ohm using the formula V upon R2, that is 1.2 upon 6, 0.2 ampere. 23rd, calculate the current flowing through each of the resistors A and B in the circuit shown below. So now this question 23 is exactly similar to question number 22. Only the difference is here voltage of the battery is given, current is not given. In the previous question, current was given and the battery voltage was not provided. Alright, so now here we can directly say that potential difference across 2 ohm is 2 volt, potential difference across 1 ohm is also 2 volt. So here we can directly use the formula I1 is equal to V upon R1, that is I1 is current flowing through 1 ohm, 2 upon 1, 2 ampere, and current flowing through 2 ohm is V upon R2 is equal to 2 upon 2, 1 ampere. And since 1 and 2 ohm are connected in parallel, the current flowing through 1 ohm and 2 ohm will be added here at this junction point, and that addition will give us the total current of the circuit. So I is equal to I1 plus I2, 2 plus 1, 3 ampere. 3 ampere. This is the total current in the circuit. 24th, in the figure, calculate the total resistance of the circuit. Total resistance of the circuit. Okay, the value of R and the current flowing in capital R. So here voltmeter is connected across the battery and it reads 4 volt, meaning potential difference or terminal voltage is 4 volt. Ammeter reading is 0.4 ampere, that is the total current of the circuit, 0.4 ampere. So using these two information, we can find out what is the equivalent resistance of the circuit or what is the total resistance of the circuit. V is equal to IR. V is 4, current is 0.4 into R. So resistance value is 10 ohm. Right? This is, let me write, this is R equivalent, so that we are not confused with total resistance and the value of R that we want to find out here. So total resistance of the circuit is 10 ohm. Okay, this was part A. Part B, value of R. Now 20 and R, how are they connected? Yes, you are right, they are connected in parallel. So we can apply parallel connection formula to find the equivalent value. Yes, we can. 1 upon Rp is 1 upon 20 plus 1 upon R. This Rp is 10 ohm. So 1 by 10 is equal to 1 by 20 plus 1 by R. 1 upon 10 minus 1 upon 20 is 1 upon R. 20 2 minus 1. So this gives us finally the answer R is equal to 20 ohm. Okay, so the value of unknown resistance R is equal to 20 ohm. And then current flowing through R. Now since 20 and R are connected in parallel with each other, and that combination is connected directly to the battery. So can we conclude that potential difference across PD across R ohm is equal to same as the terminal voltage? Yes, we can, 4 volt. So now V is equal to IR. The potential difference across R is 4 volt. Current through that we want to find, and the value of R is 20. So I is equal to 4 upon 20, 1 upon 5, 0.2 ampere. So current flowing through R ohm resistor is 0.2 ampere. Next numerical, 25th. A particular resistance wire has a resistance of 3 ohm per meter. So resistance per unit length is 3 ohm per meter. Okay, so for each meter the resistance is 3 ohm. Total resistance of the three lengths of this wire, each 1.5 meter long, join in parallel. So we have to take a wire whose length is 1.5 meter. Now since resistance per meter is 3 ohm, resistance of this wire becomes 1.5 times 3, 4.5 ohm. And then three such resistors are connected in parallel. So each wire is of resistance 4.5 ohm. They are connected in parallel. So Rp is equal to 4.5 upon 3, 1.5 ohm. Okay. So when three such resistors, three such wires of length 1.5 meter are connected in parallel, the equivalent resistance is 1.5 ohm. Next, the potential difference of the battery, which gives current of 2 ampere in each of 1.5 meter length when connected in parallel to the battery. Okay. So according to the question, when these three wires, parallel combination of them, is connected to a battery, 2 ampere current flows through each wire. 2 ampere current flows through each wire. And we know that in parallel connection, the total current is sum of individual currents, I1 plus I2 plus I3. So the total current of the circuit becomes 6 ampere. We already know what is the equivalent resistance of three such wires, that is 1.5 ohm. So now using Ohm's law, V is equal to IR, we can find out what is the potential difference provided by the battery for this purpose. So V is equal to IR, current is 6, resistance is 1.5, so this becomes 9 volt. C, resistance of 5 meter length of the wire of same material but twice the area of cross section. Okay, so when we have a wire of length 1 meter and cross section area is A, the resistance offered by this wire is how much? 3 ohm, right? That is what the initial information is given. 3 ohm resistance per unit length. Now we take a wire of length 5 meter. So let's say L2 is 5 times L, but area of the cross section is double the initial area of the cross section. What is a new resistance? R2. So we can say R2 is equal to rho L2 upon A2, that is rho times 5 times L upon A2 is 2 times area. So this is 5 upon 2 times rho L upon A, and rho L upon A is 3 ohm, right? Rho L upon A, here we can say R is equal to rho L upon A, which is 3 ohm. So 5 upon 2 into 3, 15 by 2, 7.5 ohm. Okay, so final answer is 7.5 ohm.
Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.